All right, this says, in a preparation for ClF3, 0.750 moles of Cl2 reacts with 3 moles of F2. They want us to find the limiting reactant. So the first step here, obviously, is to write our balanced equation. This is going to be one of those problems where we're being asked to find the amount of something totally different from the information that we're given. So let's see what we have here. Cl2 plus 3F2 yields 2ClF3. And where I got this balanced equation from was the previous example problem. So don't start panicking and thinking, oh my gosh, where did he get this balanced equation? Most of the time this will be given, and if not, you'll be given enough information to get the balanced equation. All right, so that's our first step. Now A says find the limiting reactant. So I know that I have 0.750 moles of Cl2. And I want to know how much product can I make from that amount of Cl2, right? This is my product, the ClF3. So I'm going to convert to moles of that using my balanced equation. So from the balanced equation, for every 1 mole of Cl2, right, my stoichiometric coefficient here is 1. I can make 2 moles of ClF3. So what is that equal to? 0.75 times 2 is equal to 1.5 moles of ClF3. And now we do the same thing for our F2, right? I know I've got sorry, I have 3 moles of that. I have 3.00 moles of F2. And I'm going to convert that to product. So from the balanced equation, it takes 3 moles of F2, right? That number came right here, stoichiometric coefficient of 3, for every 2 moles of ClF3. And again, that number came directly from a balanced equation. So what is that equal to? I've got moles of F2 divided by moles of F2 equals 1, so I'm going to be left in product. So let's see, 3 times 2 divided by 3 equals 2 moles of ClF3. Let's see. Now, I did that right. Okay. So now I have to figure out which one's the limiting reactant, and the answer to that question is always the one that you can make the least product. So I can only make 1.5 moles here, so that means that Cl2 is my limiting reactant. I don't have enough Cl2 to make 2 moles. Right? I'm never going to be able to make 2 moles. Even though I've got enough fluorine to make 2 moles, I do not have enough chlorine to make 2 moles. I can only make 1.5. So that's my limiting reactant. So let me write that down. Cl2 is limiting. Now, B part says they want us to write a reaction table for this. And so to write a reaction table, the first component is always the balanced equation. So I'm going to rewrite the balanced equation here. Cl2 plus 3F2 yields 2ClF3. And then I'm going to draw my little table here. Okay. Just like that. And now we start out with initial moles or concentrations, whatever they give us here available. So we're going to start out with moles, okay? So I know that I'm initially starting out with 0.75 moles of chlorine. So I'll write that directly under the chlorine. I'm starting out with 3 moles of fluorine, so I write that directly under fluorine. And as far as product, we always start with 0 moles of product, unless otherwise specified, because the reaction hasn't began yet. Initially, we have no product formed. All right, then the next step is we write the change in those number of moles. So I'm going to put a C there in my table, and that represents change. Now that we've identified the limiting reactant, we know how much of that we used up. Since chlorine is the negative reactant, that means I'm going to use up all of the chlorine. So minus 0.75. Now, I don't know how much fluorine I've used up yet. We're going to figure that out here in a minute. But I do know how much product that I formed over here. So plus 1.5 moles. And I don't need to write moles there. We'll write the moles in the end. So plus the 1.5 of the ClF3, right? The chlorine trifluoride. All right, so I've got to figure out now. Well, let me point this out first before I say that. Notice I used a negative sign here, minus 0.75 for the reactant, because the reactant's getting used up, right? It's a reactant. I used a plus right here for the change of the products because the products are being formed. This concentration is increasing, so plus 1.5. All right, now let's figure out how much fluorine we used up. So I'm going to start with, I know that I made 1.5 moles of ClF3. And I'm going to set me up a T here. So I want to know how many moles of fluorine did it take to make that much ClF3. So I'm going to use my balanced chemical equation again as my conversion factor, right? Because for every 2 moles of ClF3, it takes 3 moles of fluorine. So I'm going to put that here. For every 2 moles ClF3, we have 3 moles of fluorine. And then I have moles of ClF3 divided by moles of ClF3 canceling out. And let me do my math here. I've got 1.5 times 3 divided by 2 equals 2.25 moles of fluorine is how much we used up. So I'm going to put that here. So minus 2.25. And then the last part of our reaction table, we have to tally things up, so equals. So here I have 0.75 minus 0.75, which is equal to 0. Next, for the fluorine, I have 3 minus 2.25, right? And so that's going to equal 0.75 moles. And then for the ClF3, I have 0 plus 1.5, which is just equal to 1.5. And so that is my reaction table. And I call this final. So the I stands for initial, C is change, F is final. And there's my reaction table. It's made up of the balanced equation, initial concentrations, the change in those concentrations after the reaction takes place, and then the final tally, right? We add everything up, and that's what goes on the bottom.